Okay, question 8. Write a uniform rod AB has length 4 meters. So let's just draw it over here, 4 meters. Okay, so that's point A, and that will be B, 4 meters. Uniform means its mass is uniformly distributed. So its mass, 8 kilograms, will be right at the center, which will be 8G. It rests on horizontal position on supports at points C and D, where AC is 1 meter. So if that's 2 meters, 1 meter is just there. That is point C, and that is 1 meter and 1 meter. And AD, A to D is 2.5, so it is just there, and that is 0.5, which leaves this as 1.5. Okay, a particle of mass M is placed at point E, where AE is 3 points, so that's 2.5. It's over here, and it's a mass, so it's going downwards of M. Yep, M kilograms, so that'll be mg as a force, and that is 3.3 meters from A to E, like such. And there's the diagram. It says, given that the rod is about to tilt about D, so that's D, it means this mass is heavy enough that it's pushing this down, and when it's on the point about to tilt is the important thing. It means that this is providing no support at all. If you're going to pivot around this point here, it means you can negate this now. That doesn't have any effect whatsoever in the diagram. All that is keeping it balanced around this point is the weight of the rod and the M weight. We've got to find this M, calculate the value of M. So we've got all the measurements here. We do know that that is 2 meters to there, that's 0.5. So I'm going to take moments. Well, it'd be a lot easier. I'm going to take them about this point just here. So again, I want to say that clockwise is positive, taking moments about D. The only clockwise rotation is this one here, so in brackets it's positive. So I've got mg, which is the force, times by its perpendicular distance. Well, this little bit here is the distance we're talking about. It's 3.3 from here, so 2.5 take away from that is 0.8. So that bit there is 0.8. So it is times by 0.8. This one is an anti-clockwise moment, so take away, and it is 8g, and it is times by its perpendicular distance from the pivot point I'm taking, which is 0.5. Okay, and we know it's still in equilibrium, even though it is limiting equilibrium because we're on the point of tilting, it still equals 0. So I've got basically 0.8 mg, okay, minus, and a half times that is 4g is equal to 0. Divide through by g, rearrange, and you get m is equal to 4 divided by 0.8. So m is equal to, I can't bother to get the calculator, 40 divided by 8, and therefore m is equal to 5, and the units for mass will be kilograms. Okay, so that's the answer for that. So all you need to know is it's about to tilt means you're in limiting equilibrium, still in equilibrium, so it equals 0. The sum of the moments is equal to 0, but this support here has now is not supporting at all. There's no force pushing up there because you're just perfectly pivoted around that point. That's what it means. Okay, I hope that helps.